So we're going to be talking about the future of food, I guess. And I was told that I could spend just a couple minutes talking about something related to it. And I thought I'd put a picture of a cow up, first of all, because everybody likes to see a cow. But also, if I could, I'd like to spend, I'm not going to, but a half an hour talking about how integrating animals on the livestock on the landscape with perennial crops could actually go a long ways towards solving our water quality problems. But just going to go, there we go. I wanted to just do a quick overview of this whole thing of feeding the world. I just saw that the other day driving down the road in Iowa. And agribusiness kind of promotes that we're feeding the world in Iowa. But who really feeds the world? Actually, some data that came out about a year ago, 70%, and Mark Bittman mentioned this last night, 70% of the world's food is produced by the peasant food web. The small farmers around the world, they produce 70% of the food. And they only use 30% of the ag resources that are used for producing food to do that. Whereas the other 30% of the world's food is produced by the industrial food chain, which uses 70% of our resources. So I won't say more about, just think about that for a little while. If we're going to try to ramp up that second group to feed the world, what does that mean? But already we know people talk about, well, there's going to be 10 billion people by 2050. Already in the world, there are enough calories to feed the 10 billion people 4,000 calories a day, and 2,700 calories a day are what we need. So we have already enough food, so why are there hungry people? Well, 1 billion people nearly are hungry. And we know it's poverty. People say it's lack of distribution. Well, it's not like there's a shortage of distribution trucks. The problem is that people are not empowered to be able to procure food. For example, India has the most hungry people in the world, but they export food. And that kind of puts perspective on how we're going to feed the world. We're not going to feed the world from Iowa. And UN's done some interesting studies recently, an analysis of 144 development projects in 24 countries in Africa. And they found that when organic practices that maximize the use of on-farm resources were used at double crop yields. Now these are the small-scale farmers that are feeding the world, that they can double their crop yields if they can maximize the use of their available resources, and as well as some of the other environmental effects from that, benefits from that. And others said, I think in University of Michigan, 293 data sets. In developing countries, yields of organic and conventional crops were similar. At ISU, for example, their long-term study shows corn and soybean production are similar for organic and conventional. But in developing countries, organic yields were higher. And so we have to rethink about who's going to feed the world and how we're going to do it. And Hans Herren, who won the World Food Prize in 1995, he put it in perspective, I think. He said that GMOs are a huge distraction from feeding the world. The idea that we're going to take all this industrial technology from our world and take it to the third world countries is a huge distraction from what needs to be done there. Because he said there is a large ecological yield gap in developing countries. That if we can just maximize our use of the ecological resources, we can make tremendous yield gains. And if we can have food sovereignty around the world, that's much better than trying to feed the world with corn and soybeans produced in Iowa. I think that's one more thing I want to do as a passing thing. There's been a lot of talk in times that some ag groups are telling us that the nitrate levels in the Raccoon River have been declining. But if you look at the data they use, they pick the data from 2006 to about here, and they have a downward trend that nitrate levels are declining if you take that little piece of data. And that's been used a lot around Iowa, that nitrate levels are declining because we're doing something really great out there. But that's really deceptive. I just got this data from the DNR water monitoring program, and the best fitting line over the time, and we can see how the historically high spikes are from right now, and so that's really bogus data, and I wish they'd stop using that. Anyway, let's go on, and our first speaker is Matt Liebman. Now Matt is a professor at Iowa State University, and he sits on the Wallace Chair for, the Endowed Chair for Sustainable Agriculture. Matt he got his BA from Harvard, and he did his PhD at Berkeley. And actually, Matt's been in the news in recent years for his work on diversified cropping systems, in that he, actually, New York Times has written him up a few times on his work in diversified cropping systems. Maybe he's going to talk about that. Matt?
I want to talk this afternoon about on-farm diversification to protect Iowa's soil, water, and wildlife. And it's going to draw on some of the themes we've heard earlier, but I want to spend most of the time talking about what we can be doing to address the problems that have been stated previously. If we look at Iowa, what we see is a very simplified and homogeneous landscape. That was done by conscious design. It's driven by economics and technology, but it has very strong consequences in terms of economics as well as environment. This is Wright County, north of where I live, almost 600 square miles, and corn is in yellow, soybean is in green. You see a little bit of riparian areas flowing from northwest to southeast, a couple of towns, maybe one or two small lakes. But almost the entire landscape there is composed of 2 annual crops that grow about 3.5 months a year and have shallow roots. That's a problem from the standpoint of protecting water quality. It's a good thing for an industrial infrastructure that is specialized in harvesting those crops and selling them in international markets and putting them into livestock and ethanol plants. And as we heard earlier, Iowa is typically number 1 or number 2 in corn and soy production. We lead in chicken egg production. We're usually number 1 in hog production. I think we're something like 5th or 7th in cattle production, beef cattle production, and we're the number 1 ethanol producer. So this translates into a lot of income at the farm gate in a good year, somewhere around $30 billion a year. But that lack of diversity in the landscape, both within and around fields, translates into a number of emerging and continuing challenges, including soil erosion, water quality degradation via nutrient and pesticide emissions, an increasing number of populations of herbicide-resistant weeds, new crop diseases like sudden death syndrome in soybean, volatility in farm economies due to fluctuations in crop prices and input costs, and reductions in wildlife populations. The most talked about species right now is the monarch butterfly. So I want to talk about what can be done to address some of these things. I'll address 3 different studies at 3 different levels of scale. One is sort of plot and fields. This is a cropping system study being done in Boone County, Iowa. I'll talk about a small watershed study that you've heard bits and pieces of, the so-called STRIPS project that started at the National Wildlife Refuge in Prairie City. And then I'll talk about a landscape modeling analysis that was conducted for Western Iowa. So the first question I want to address is, can diversifying corn and soybean systems with small grains and forage crops reduce requirements for agrochemical inputs, maintain or improve productivity and profitability, and improve certain environmental performance characteristics? This is a 22-acre study being conducted in Boone County. It involves 3 crop rotation systems, a 2-year cash grain corn soybean system matching what most commercial farmers in the surrounding county are doing, and 3- and 4-year systems that are more diverse. They include a small grain, oats, and forage legumes in the form of red clover grown as a green manure and just plowed in the 3-year system, and alfalfa harvested for hay in the 4-year system. Were I farming commercially, and if I seeded alfalfa, I wouldn't just keep it for 2 years. The seeding year and the following year, I would continue. So that's an artifact. That 4-year rotation is an artifact of a limited amount of land and wanting to have every phase of each crop rotation present every year. These plots started in 2001 after we cropped the whole area to oats, ran a yield monitor over the whole area, sampled soil, laid it out in a statistically rigorous fashion with 4 replicates. There are 36 plots, 60 feet by 275 feet each. That translates into 24 rows of corn and soybean. We use typically 6-row equipment. All right, so in this sense of diversification, I'm including the integration of crop and livestock systems. In the 3- and the 4-year system, composted cattle manure is applied to the red clover and the alfalfa before corn Nitrogen is added by the production of the forage legumes, clover and alfalfa. So the residues of those two crops add nitrogen to the soil. The return of the manure brings back some nitrogen, but perhaps more importantly, returns a lot of phosphorus and potassium. These more diverse crop rotations also manage weeds with more diverse tactics. We use a banded application of herbicides over the corn and soybean rows. We then cultivate between the corn and soybean rows in the longer rotations. We also get some cultural weed control when we grow a small grain like oat. We harvest it in mid-July. That harvest operation interferes with the life cycle of summer annual weeds that typically infest corn and soybean. We typically clip the stubble 4 or 5 weeks after harvesting the oats and then allow the legumes to grow, which compete against the weeds. All right, so let's look at the consequences of doing those kinds of things. In terms of nitrogen fertilizer, the mineral fertilizer inputs have dropped about 90% in the 3 and the 4 year rotations relative to the 2 year rotation. And you can see in the corn phase, we use some fertilizer nitrogen. We test the soil, we add some mineral fertilizer based on that soil test, but we've been able to reduce the inputs quite a bit. The small quantities you see in other crop phases refer to monoammonium or diammonium phosphate, which add some nitrogen when we're topping off the phosphorus with synthetic fertilizer. Herbicide reduction has been on the order of 96 to 97%. You can see that the corn and soybean phases are the only ones that do receive herbicides. So we've seen a reduction by not applying it to the small grain and forage legume phases. But even within corn and soybean, we've been able to reduce the amount of active ingredients applied by putting small quantities of post-emergence herbicides in bands over the crop rows. What have been the consequences for yields? Well, we have statistically significant increases in corn and soybean yields over long periods of time. These trends are very consistent. They vary from year to year depending on whether we have a hailstorm or a drought or a very wet set of conditions. But statistically, we've increased our corn yields about 5% in the 4 year rotation relative to the 2 year rotation, and we've increased our soybean yields on average 17% over the 2 year rotation. So by giving up large quantities of synthetic fertilizers and pesticides, we have not compromised the yields of cropped soybean and corn acres. We are growing fewer acres of corn and soybean, however. What about the labor and economic consequences? Labor inputs go up when you make hay, when you spread manure, and when you cultivate. So as we move to these longer rotations, the amount of labor required in terms of operating the tractor and other equipment goes up. But it's still all being done by machine. This is not hand labor. The gross returns over the period that we evaluated from 2008 to 2013 were higher for corn and soybean grown in this shorter rotation. But the costs of production were also higher. More fertilizer, more pesticide, more gas to dry the corn grain in a wet year. So when you look at the net returns to land and management, numerically, the 3 and the 4 rotations come out a little bit ahead. Statistically, they're equivalent. So we're not giving up anything in terms of profitability, and we are charging ourselves for the labor that's involved in this additional extended crop rotation. We've evaluated quite a few soil and environmental parameters. I'll just give you a couple of things here. The estimated sheet and rill erosion due to rainfall in terms of tons per acre per year is higher in the 2 year rotation than it is in the 3 and the 4 year rotation. Even though we plow alfalfa and red clover, and we don't use a moldboard plow in the conventional corn and soybean system because we have more cover on the land with small grains and the forage legumes, our erosion potential drops. We've evaluated herbicide-related aquatic ecotoxicity using life cycle assessment tools. My colleagues at the University of Minnesota show a more than 200-fold reduction in the aquatic toxicity potential in the 3 and the 4-year rotation relative to the 2-year rotation. In terms of fossil energy use, we have more than a 50% reduction in the use of fossil energy in the forms of mineral fertilizer, principally nitrogen, gas to dry corn grain, and fossil fuel to operate tractors and other field equipment. So the conclusion that we came to from this study was that increasing cropping system diversity can balance productivity, profitability, and environmental health. We published that result in 2012. To date, we've had nearly 42,000 downloads and page views of this technical article. So in my entire scientific lifetime, I've never done anything that seemed to resonate with either members of the scientific community or the public community who are interested in the details of crop production in a manner that bring both agriculture and environment into the picture. The second question I want to ask is, can diversifying annual cropland by converting small areas to perennial prairie vegetation provide conservation benefits that are disproportionately greater than the land area converted? This is the STRIPS trial that you've heard about. STRIPS is actually an acronym for Science-Based Trials of Row Crops Integrated with Prairie Strips. This is a team effort supported by multiple agencies and funding groups. You can see some of them on the bottom there. If you want to learn more about this project, type in prairiestrips.org and you'll get to our website and you can find extension bulletins that tell you how to do this, and technical articles that report the details of our scientific findings. So, as you heard before, it involves experimental watersheds at the Neil Smith National Wildlife Refuge. These were established over a period of time. Starting in 2003, we started walking the land, and by 2007, we had implemented the cropping systems. 4 treatments, 100% no-till corn and soybean grown in alternate years, 10% buffers at the foot slope, 10% buffers as shown here in contour strips up the slope, including at the foot slope position, and 20% buffers in contour strips. A cartoon looks like this. I think you've seen this several times this morning. The important thing to understand here is that all the crops are grown with zero tillage. Okay, so this is supposed to be the standard for soil conservation. Why prairie? Prairie differs from cool season grasses like smooth brome, which are typically used in waterways. Waterways are designed to convey water while holding soil. When that water moves, it conveys sediment. Prairie strips are composed of species that have stiff, direct stems that impede the movement of water, slow it down, increase infiltration, and increase the amount of sediment and nutrients deposited on the upslope side of the strips. Within 3 years of establishing these strips, we had 33 native species, 33 native perennial species growing there. We monitor the surface water coming out of each one of these small catchments. We have what are called H-flumes that collect water and allow us to look at both the quantity and quality of that water. As it flows through, small samples are taken in a flow proportional manner. They're analyzed for nutrient composition, and we measure the amount of soil sediment flowing out of the bottom of the watersheds. So here is one of the more salient results. What you see is the dark line in each year is the 100% row crops grown under no tillage practices have significantly more soil sediment flowing out of the bottom of the catchments than do any of the prairie strip treatments. The prairie strip treatments are effectively equivalent, and we get a 95% reduction in the amount of sediment export from the watersheds with the prairie filter strips in place. It varies from year to year in terms of magnitude, but the relative differences have been very consistent. So with a 10% change in land use, we're getting a 40% reduction in water runoff, an 84% reduction on average in total N losses and runoff, and a 90% reduction in total phosphorus losses in the runoff. So that's what I mean about a disproportionate benefit. A 10% change in land use gives these larger changes in nutrient and soil emissions and water runoff. What about some of the wildlife indicators? Birds of conservation concern have been important in our study. We've seen that catchments with prairie strips had 2.6 times as many bird individuals and 2.3 times as many species of birds as the all-crop catchments. We've seen no influence on per acre crop yields, although of course we're cropping less land with corn and soybean. But in those acres that are cropped, we're not giving up yield by putting the strips in. We've seen no additional weed issues in the cropped areas, but they are being managed with herbicides applied by the farmer who follows fairly conventional practices on the areas that are cropped. We're now moving towards what we call strips phase 2. We have our first adopter, farms 3 separate enterprises down in Page and Taylor counties in southern Iowa. He put in strips in 2012. This is what the strips look like. He's a cattle producer, and he grazes his prairie strips. He produces cattle as well as corn. The potential for harvesting prairie strips as a biofuel substrate exists. We've looked at the yields. Dry matter in our prairie strips at the Neil Smith Refuge has been on the order of about a little over 3 tons of dry matter per hectare. We don't know where the cellulosic ethanol industry is going, but this is one potential place where we can combine conservation and fuel production. The final study I want to talk about is a modeling study. The lead author is luckily in the room, so any questions can be directed to him. This is addressing whether diversified crop livestock systems can affect soil erosion and the amount of potentially leachable nitrogen at a landscape scale. This was conducted in watersheds with headwaters in Crawford and Shelby counties in western Iowa. This is on lush soils, steep slopes with a high erosion potential, and was published in 2005. We compared 2 different scenarios. One is current conditions for crops, non-agricultural vegetation, cattle and hogs, and the alternative conditions comprised more land in small grains, forages with riparian buffers and eco-reserves, decreased land in corn and soybean, and increased numbers of cattle and hogs. No synthetic fertilizer was applied in this alternative scenario because of nitrogen fixation by the forage legumes and manure recycling. You see the existing land use pattern on the left side with row crops being in yellow. You see the 2-year rotation is yellow, and the longer rotations used on upslope areas in green and riparian buffers in dark green on the right-hand map of land use. Predicted soil erosion dropped dramatically. The T-value, the so-called tolerance value, was exceeded in most of these watersheds under existing land use, whereas it dropped below the T-value under alternative land uses. And when we did a nitrogen balance, we could see about a 67% reduction in the amount of potentially leachable nitrogen that was in the soil available for loss if rainfall events were to move it into the groundwater. So this is a modeling study. It's basically a hypothesis, but it sets a research agenda that would say integrated crop livestock systems and more diverse crop rotations offer potentially very significant benefits in terms of soil erosion control and reductions in nitrogen in water. So to conclude, I want to point out this quote from Aldo Leopold. He said, "The outstanding scientific discovery of the 20th century is not television, radio, other forms of technology, but rather understanding that the land organism is complex." So as we think about how we're going to address water quality issues and other challenges for agriculture in Iowa, I would like to stress that we should focus as much on the biology and ecology as we do on the technology. Thank you. The basic challenge I get from most farm groups is, if you grow less corn and soy, they'll be worth more, and people will move back to growing them. If you grow more alfalfa and oats, they'll be worth less, and people will be less interested in producing those. So we have to create a demand, either through integrated crop livestock industry or other uses of small grains, and hey, yeah, I don't deny that. So the question is, how do you deal with prairie species intruding into tiles? So where we're growing these strips, they're on hilllands that are not tiled. If we're growing these strips on hillsides that are not tiled, if you were in a landscape that was tiled, I would agree that you probably don't want to put your prairie species right over the tile line itself. So, I mean, you can control the placement of the strip, right? You have to know where the tile is. We have one study where we've been growing prairie directly over tile lines, and we have not seen plugging. But, you know, that's only been in place for 8 years, so I can't speak to that. Okay.
Getting used to how to run these things, how to drive. Thank you, Matt. So our next speaker is Lori Abendroth, and she heads up a large project of 140 scientists and others. It's a multi-state team looking at the environmental, economic, and social impacts of long-term climate variability on corn-based cropping systems in the Midwest. Lori?
So I think Francis should get a gold star for keep climbing up here to introduce all of us. And I know I was placed at this location in the agenda. I don't know if anyone else has noticed, but I follow Mark, Matt, and Matt. So I think it's time for a Lori. So great to be with you here today. And I see now why everyone kept adjusting the microphone. It moves on you, doesn't it? So I think one of the good things about coming in the afternoon is that you've all been listening to a lot of different perspectives and opinions and trying to gel those together, and I've been doing that as well in the back. And obviously you can see there's a spectrum of understanding and opinions, and I think conferences like these and conversations really help to expand and help us all move towards a greater understanding and kind of moving beyond polarization like Matt had talked about, but just asking good questions with a lot of humility of how do we make improvements? How do we look at some of these global challenges that we face not only today but in the future? How do we face these as a society that brings communal good? So I manage a large team, as Francis mentioned. I am based at Iowa State University, but I manage 140 scientists, staff, educators, and students tasked with a 5-year challenge of looking at how do we not only improve the sustainability and better understand our footprints in agriculture, but also how do we improve the resiliency of agriculture to a changing climate. So when I say resiliency, that really means how do we have the system be able to absorb more of the risk and still respond productively. So climate change, when people talk about it, is really a risk multiplier. So USDA-NIFA, United States Department of Ag, National Institute of Food and Agriculture in 2010 looked nationwide at our agricultural systems and identified their limited capacity to adapt and mitigate to climate change. So in 2011, they put forth a request from universities to develop proposals and in those proposals, hopefully find solutions of how do we adapt our agricultural base in the United States to climate change. And so we were one of the first funded teams, one of the largest funded teams working within corn production to identify this beginning in 2011, and we have 5 years. So if anyone can do the math, that means in 2016 we will be done, or at least finished with funding to really tackle some of these complex issues of sustainability and resilience. So that's what I'm hoping to go over a little bit today. So when I talk with groups, whether they're rural or urban, as we've picked up today, there's huge perspectives and differences of opinions. And so I think our frame of mind and what we expect our agricultural systems to develop is based on what do you think the primary and major goals of an agricultural system should be. So we've talked about, is it for food production here in Iowa? Do we really produce food? Or is it feed or fuel or whatever? I'm going to say that farmers will respond to whatever the markets demand. Currently, the markets in the US or in the Midwest want corn and soybeans. That's what farmers are responding to. If we have economic drivers in place for conservation or for other crops, they will respond to that. So I've put just a few of what I've sensed from others when I meet with them. There's more of these. Do we expect agricultural systems to produce the greatest amount of yields from the land? Have the highest efficiency, meaning inputs equals outputs, 1-to-1. Do we want to minimize the use of external inputs, such as fertilizers, pesticides, irrigation? Do we want to make our existing crops perform better? Or do we want to diversify and introduce new crops? Do we want the same amount of food available every year at the same prices for consumers? Do we want to ensure that everyone has a minimum required caloric intake around the world to ensure that we don't have stunted growth and limitations in certain countries? Do we want to ensure that everyone has a rich diet with fruits, vegetables, and protein from meat? Do we want to increase agricultural productivity across the globe, and so forth? So I think you can see that based on what your primary goal, what you identify out of here as the major goals, that's going to shape what you think is important from a policy, from a production, from an implementation standard. So we're all wrestling with how do we capture the most of these and really have the best system in place. This picture is always pretty striking to me, and I want you to focus on the big orange and the little blue. And I don't know if any of you can tell me what this is a pie chart of, but this is US agriculture. So 2% of the population farm for a living, that's the blue, and the orange is everyone else. So 98% of the population do not farm full-time for a living. That's obviously great in a lot of ways with mechanization. That meant that a lot of the people growing up in rural communities decades ago were able to maybe do something else because they were freed from being in those labor-intensive jobs. They were able to go into the cities and do other jobs and contribute to economic development in that way. What I think this does mean, though, is for all of us, whether you're in the blue or the orange from your perspective, there's always a need to lean into and listen to the other groups. So the orange is great because we have the majority of the population coming from that perspective, and I think we see a rise in passion and interest in our food systems and where our food comes from, which is really good. But then we also have to recognize that that 2% are the ones that are actively working on the landscape to produce that food or feed or fuel. And they also have a really important voice in it that sometimes can be drowned out with the orange mass. So we want to always have a real listening posture. And here's just some numbers for that. So 2% farm for a living, only 17% live in the rural areas. And even with that, if you live in the rural areas, that doesn't mean you understand agriculture. What I've noticed is many people, maybe their grandpas or great-grandpa farmed, but they're several generations removed from the farming operation. So that's great that they come from that background, but that also means that they can be antiquated views or knowledge gaps or misunderstandings that abound quite a bit. And I see this in press quite a bit when I read agricultural pieces. I'm glad it's in the press, but I would say probably at least 90% of the articles, whether in newspapers, magazines, blogs, have misunderstandings either from slight to gross misunderstandings of agriculture. So we need to understand we're recycling this information in a way that could perpetuate things that aren't helpful in progress towards sustainability and resilience. And then I think too, everyone wants food when they want it and they want what they like. So we have consumers that expect a stable food supply, low prices, despite weather and unpredictable situations. So I contend that the manufacturing of food, feed or fuel, is the most complex complex manufacturing system in the world. So if you think of it, other products that we manufacture, maybe it's tires or cars or whatnot, you have to get the source, so the inputs, but then you control the whole manufacturing system under a roof where you can keep everything progressing at a linear flow Whereas farmers, they're trying to manage a small piece of land, whether that's 2 acres or 200 acres, relatively, it's all small. They're trying to manage that microenvironment to have maximum productivity and output year in and year out when it's exposed to weather, anything. Precipitation events, hail, flooding, temperature swings that they can't predict when they plant the crop and plan for it. So that's a real challenge. So one of the grand challenges that I think we face as a society is how do we allocate and address the food production, resource allocation, and environmental stewardship, not only now, but in the future. I think it'll become more challenging. I think that requires a change in how we all view food production and expectations from it. Really a necessity is to have science-driven policy incorporated into recommendations or regulations, which sometimes is limiting because of that limited group that understands agriculture in and out. And then climate change is adding a new layer of complexity to agriculture. So however long we've been producing corn and soybeans here in Iowa, we've done well in a lot of ways, and we've been able to understand the system, the genetics, the management, the environment, but all of that is changing now with a more extreme climate. And when I talk about climate change, I'm not concerned about what you think are the motivations necessarily for it or whether or not it's happening. I think we can look at data and say pretty consistently that the weather's changing. So farmers have to deal with this more extreme weather volatility and weather variability, and that's what our team is looking at. In general, when we talk about climate change, it's really hard for us on an individual and also societal level to address it. And I think I've highlighted just a couple reasons here. Generally, we underestimate or don't notice slight incremental changes. It's just like weight gain. If you eat too many cookies one day, you're not going to notice that you've necessarily gained weight, but it's a pattern over time if you would eat that many cookies every day. And it's that type of thing with climate change. It's very hard to tell 1/10 of a degree of an increase on average per day when you're going about your day. You just can't tell it. Or a slight change in the precipitation when there's quite a bit of variability. What we're really needing to look at is long-term patterns to be able to tell those climate shifts. And then also greenhouse gases are invisible, and grasping the longevity of their impact is difficult. So you think of smog or something, you can tell when you've got smog in an urban population. You can't tell carbon pollution in a city. So in agriculture, I thought this quote really summed up what we're faced with. And I'll read it here in case it's probably hard to read. The uncertainties are due to the complexity of the system, the agricultural system. The incomplete basic understanding of some of its parts and of their interactions, and the fact that the system is rapidly moving outside the bounds within which historical observations exist, and the fact that human activities will change both the trajectory of climate change and the vulnerability of the affected people and places in ways that are not fully predicted. This is the scope of what we're faced with. Having an incomplete understanding of our agricultural systems to date, and then also adding in this climate change factor that none of us can fully comprehend. So the question is then, what can we do to meet the challenges and assure sustainability of our human, water, and land resources? So as I mentioned, the team that I manage, we comprise 11 institutions across these 9 states. You can see the logos up there. No University of Iowa, but no, nothing against you guys for that. So, why are we focused in this region and particularly on corn? Corn, as you've seen in previous maps, dominates this part of the U.S. It's a major cereal crop in the United States, and we look at it because it's one of the major grains in the world. So 75% of the world's caloric intake comes from corn, rice, soybean, and wheat. These grains are highly transportable, have good longevity and storage, and that's why a lot of the caloric intake comes from those. We also have a lot of efforts in breeding and management to understand them. 70% of the U.S. corn crop is produced in these 9 Midwestern states, these right here that I showed you. So the task for our team is, if you can adapt corn, we're the ones that should be able to do it. If we can adapt and build the resiliency of this corn-based cropping system to climate change, we're the ones most likely in this part of the world to be able to best show how that's done, and that's what our team is working on. You've all seen this. This is the U.S. corn acreage from 2013. Nothing here other than showing Iowa's in the dominant area. So when I talk about extreme weather and weather variability that we face now and in the future, and that I think we all need to be aware of, this is what it looks like in the Midwest. Increasing carbon dioxide concentrations is a concern globally, but its impact varies locally. So what the impact of that looks like here in the Midwest is very different than what it means along the equator in Africa or in Brazil. It has a location-specific effect. In the Midwest, that means longer growing seasons, so we've shifted our frost dates. We have warmer winters, so that affects the kill on insects. That's why up in Iowa we don't have huge insects like in warmer climates, because we have those harsher winters. Warmer nights. The warmer nights is a real concern in grain fill period for crops. So if the crop doesn't move below a certain threshold at the nighttime, basically it's expending energy throughout the night, and that's taxing on the plant. So warmer nights stress plants. More frequent severe precipitation events. And this is especially true in the springtime, and this is especially important for Iowa as we talk about water quality. So you can see nitrate concentrations moving into the streams, and some of that I contend would be directly related to these severe precipitation events. So because we have more intense rainfall in the spring, that puts more stress on our systems when the crop is not there covering the soil. We have greater annual stream flows and increased humidity with the canopy, which affects pest pressure, diseases, and insects. So here's just an example I throw up as to why crops and temperature matter. The green is the optimum range for vegetative growth in corn. The purple is the optimum range of temperature for reproductive growth. You alter the temperature patterns in the region, and you're moving possibly outside those optimum ranges. And that's why, by and large, everyone predicts decrease in yield with climate change. So our crops cannot adapt quickly enough to that change. We've already talked about some precipitation aspects. I'm going to move on to this so I can make my time. So when we look at farmer stages of adaptation, when we look at how do we improve the resilience, really only 5 minutes? Okay, thanks. How do we improve the adaptation? There's really 3 stages that we look at. First stage would be you're going to try and manage the climate change disturbance with making minimal changes, such as planting date hybrid selection. Then you're going to make moderate impacts, or the climate change has moderate impacts on the system, but it still be able to retain its form and function. And then the third one is really you've got to transform whole systems and crops that are grown in the region. Our team is working on stage 1 and 2. One of the most important things we did up front was we asked farmers first, what did they think about climate change? Are they concerned about increasing weather variability? And do they feel that they can adapt, or do they need support? And I think the farmer voice in this is really critical and important. Basically, what this slide tells you is we surveyed 5,000 farmers across the Midwest having $100,000 or more in gross revenue, and that represents 80% of the farmland. Important in this is their climate change beliefs. So we broke them into 5 categories. First one, climate change is occurring and caused mostly by human activities. 8% believe that in 2012. Second one, climate change is occurring but due both to human and natural causes, 33%. Next, climate change is occurring but caused mostly by natural, 25%. And then the final one, there is not sufficient evidence to know with certainty whether climate change is occurring. The main thing I want to show you here is that if we sum those first 3, what that tells you is 66% of farmers believe climate change is occurring, and 41% believe humans are at least partially responsible. We also asked them questions about how does that impact your farming operation from risk and the system's ability to respond. This shows you their responses on the Huck watershed levels. So you can see Iowa's there in the middle. Basically, the darker blue is higher agreement, less dark blue is lighter blue is less agreement. So those, where Iowa's at, we've got 60% of farmers that say they're concerned about more frequent extreme rains, so they're very cognizant of it. But what's interesting is we see a breakdown or a separation in perspective based on what they view climate change is caused by. So there, for example, on the left-hand side, the blue bar on the left says 60% of farmers who believe that climate change is mostly occurring due to human causes are the most concerned about excess water. Whereas if you don't believe it's occurring, that lighter blue all the way down, you can see basically a downward progression. Then those farmers, only 24% are concerned about excess water issues. So you have to have different approaches to reaching these different audiences. Same with concerns about soil erosion and nutrient loss. We have 45% of farmers concerned about this if they believe climate change is occurring, less if not. So these are the real things that we're dealing with of how do you focus conservation practices across such a different audience and understanding and perspective of what the challenges are to their operation. Our team is looking at a whole host of things that we've already talked about today: crop diversity, incorporation, cover crops, perennial, annual crops, soil management practices such as tillage, different nitrogen treatments, timing aspects, drainage, and crop management. I'm going to go right to my conclusions and just show you a few pretty pictures. Here's water quality testing that's being done. Here's a picture of why cover crop research is so difficult. This is taken on the same day. The left is in Indiana, the right is on Iowa on March 26th. So cover crops are obviously temperature dependent. Iowa's a colder environment, so their implementation and potential varies on a regional basis. Primary outcomes of what I'd like to focus on and leave you with today: climate resilience of agricultural systems. One, many farmers are concerned about the impacts of climate change. Most farmers think that they and other farmers should do more to protect the land from increased extremes. And our research finds that to hone in on that, you always work off of farmers' strengths to adapt and respond to risk and weather variability and their capacity to do that exceptionally well. Practices that increase resilience, such as no-till cover crops, better management of the system, also have water quality benefits as well as mitigation. So if we focus on adapting to climate change, you'll get a whole host of benefits. And finally, they can't control the yearly weather, but farmers can manage the system to increase resilience in short-term and long-term strategies. And it just depends if you're looking at next year or 10 years from now. But with that, I will end. And there's our website if you would like more information, or I'll be in the back of the room. Thank you. Sorry, okay. Yeah, that's a great question. So there's 30, the question was on how much field research is being done. There's 35 test sites across 8 states. So those 35 sites, we're using both currently established sites as well as we established some new sites in 2011. Each site slightly varies in the treatments and the data collected. Overall, we have 55 treatments that are across all 35 sites, and we're collecting up to 90 data types. So it's pretty comprehensive that we're going across carbon, nitrogen, water, contents of the soil and the plants, and greenhouse gas. So.
Oh, everybody said that's fine. Okay, that'll work. So our first person, each of these 4 will talk for about 5 minutes or maybe a little more, and then we'll have questions at the end of that. So our first presenter will be Dick Sloan, and Dick is a farmer, and he started farming in 1978. He raises corn, soybeans, and hogs. But he and his neighbors started this Lime Creek Watershed Improvement Association. They're working to look at how crop rotations and tillage and fertilizer can reduce nutrient loss to the environment. And so,
Well, so I guess there's been, yeah, long. So I've been a biologist, is how I've considered myself as far as a farmer. I studied biology in school and then started farming because I had that opportunity. So it's a good thing to do. But I was always interested in how the farming impacts the environment. And so when some of the descriptions about what we might do as a watershed group, we were encouraged in 2006 to form our Lime Creek Watershed Improvement Association so that we could test out some performance-based incentives. If you're interested in some of that stuff, you can see we did get it. If you go to our website, there's a lot of good information there. The WERB grant we had for 3 years to continue the practices and build on it. We had some good results, some positive years, and then other years where you'd feel like, gee, are we really making any progress? And so you just keep going on it, I guess, is how you farm. You know, you make mistakes every day, and you just keep going anyway, I guess. So I've adopted cover crops on all my acres, and I'm a real fan of the NRCS Soil Health Initiative. Some of the funding to get me going in it was available through the CSP program there, and covers it, by making that commitment on all my acres, why I was able to cover the cover crop seed during the 5-year transition period. What I've learned in the years that I've been cover cropping and going to conferences and sharing information with other farmers is that we figure there's probably about a $50 to $100 payback on cover crops. It's just not immediately obvious to a lot of farmers what those paybacks are going to be. So that's meeting with farm groups and being out there and doing those sorts of things. I think that if we're effective in those being leaders, why then we'll be able to show what's going on there. I guess on the left there, you can see my tractor. That's my big tractor, 2-wheel drive unit. Not doing any tillage, I was able to get rid of some equipment and make commitments to it. The screen on the right shows that I'm all GPS modern, I guess. The planter shuts off and on different rows. You can see the little blue bars at the bottom. There's 4 rows that are on. If you look at the little planter in the screen, it looks like there's 6. So each of those little switches, the green and yellows, controls so that as you plant through areas where you've already planted, the planter can shut off seed and save money. The little blue bar clear over to the right shows you that I've smashed a wire on my planter, and things don't always work this way they're supposed to. So, then on soybeans, I'm planting soybeans and corn at the same time, and I use rye ahead of soybeans. It does really well. Rye is a very hardy crop. It'll grow when it's 34 degrees. You know, it's like the first thing that's going to green up in the spring and get a lot of growth out of it. And soybeans, being a legume and a dicot, are going to not have allelopathic issues with the grass of the rye, where the corn, there's some concerns with particular bugs and insects that are brought in by having a rye cover, and so learning how to manage some of that stuff. But I got a couple pictures here where I don't really need words on there. This one was, that first shot was at my home farm. This is also at the home farm where I'm standing on top of a grain bin and take a picture off toward Rowley in the distance back there. If you've got good eyes, you can spot their water tower. You can also see that you get to the edge and there's green and over a couple of hills, and then it's not green anymore. This is another one that kind of shows the difference. So you can kind of tell where the edges of my farm are. I guess that's, one of the ways that I'm dealing with that low growth rate for cover crops in Iowa, and I'm in northeast Iowa, in Buchanan County. I'm dealing with it by planting into green cover and learning what species to use in my mixes. I don't plant any one species alone when I'm flying. Some of the acres I fly on, I've got 700 acres. We drilled about 400 last fall and flew another 300 on earlier in September. This is a picture of the cornfield where I showed the planter earlier operating. You can see the corn there, and basically what I try to have my cornfields look like in June is just like everybody else's cornfields. So if I can do that, why, I'll do all right. This is a picture where we were installing our new water monitoring stations. We're interested in knowing more accurately for individual farmers what the impacts of different management changes are for their farm. And so 9 of us, I guess, I've got 2, but we're installing these so that we can monitor water flow out of our tile lines. We have weather stations nearby so that we can compare tile flow with soil types and water rainfall events and recording temperatures. And so we'll have different crops and different fields and different farmers managing those different soils. And we think that in the long run it'll give us a nice, this is a picture of my strips that I have near my farm. Dr. Jackson took this last summer out there. So I do have some prairie strips too involved. So I guess I'll wrap my talk up there and let the next presenter.
Thank you, Dick. Wow, if every farm was like that, it'd be amazing in Iowa, driving down the road. Next we have Jason Grimm? Okay. And Jason works as the food system planner with the Iowa Valley RC&D, and he works on mostly local food stuff, but he works in 9 counties on a variety of projects, and maybe he'll tell us about what they are.
Because they limited my bio, I'm also going to talk about that I farm too, so I'll talk about that as well. So I wear 3 different hats. My full-time job is with the Iowa Valley RC&D located in Amana as our food system planner. And then in that role, I founded with a collaborator of mine, the Iowa Valley Food Co-op, where we're helping market products for local vendors within our region. And then I get the pleasure of farming with my grandfather and my dad as well. And I'll talk about those enterprises too. In my full-time work, I coordinate 6 different program areas. During the winter months, we do a lot of training for producers on market development, food safety stuff, pretty much whatever farmers ask me to give them a workshop on. Every year we collect metrics on our food system to understand what kind of impacts people marketing things locally is doing for our economy. We do this with others across the state. So over the last 2 years, we've documented 171 new jobs that have been created in the state with a value of only $15,000 per full-time equivalent for taxpayers to create those jobs. And we've also shown statewide in purchases by institutions and buyers that give us their purchases, about $22 million worth of purchases and or $23 million worth of sales from farmers that have told us how much money they made. The Come to the Table program, that's how we help get producers and institutions or school districts, restaurants to meet each other. It's all about relationships. So I call it my annual speed dating event for the food system. The Iowa Valley Regional Farm to School program. With that program, we're doing a lot on helping schools make agreements with farms to purchase fruits and vegetables during the school year. So because schools receive state and federal funding, we have to help them create bid request documents to send out to farms for farms to send bids back. One of the programs, tools we created is this Iowa Farm to School Toolkit, which is a web tool that schools can use to help find templates to create bids and to create agreements when purchasing from local vendors. The Iowa Valley Food Co-op, we were founded in 2011. In about 40 hours a month, I manage this as well. We operate year-round. We operate 100% online. We market everything through our website or through our mobile shopping app. and individuals are able to log onto our websites and place orders. They do that by choosing their vendors they want to, or what products they're looking for. We're a online grocery store in a way. And in the last year, last summer, we started moving into doing wholesale produce distribution as well with Hy-Vee. As I mentioned, I farm as well with my grandparents and my parents and my wife. Our farm, total farm, is 125 acres. Growing up, I always called it my dad and grandpa's expensive hobby. And so today I'm more interested in helping them find ways that we can diversify our cropping systems to someday make it a full-time job for myself. Growing up, we always just marketed corn, oats, and hay. The crops were never sold. The only thing we actually marketed off the farm was cattle, or we used to ship milk off the farm too. Today, I manage 3 different enterprises that this coming season will take up 15 acres of the total farm. We do about 1.5 acres of produce. 1 acre of that is potatoes. That's in the top right. You'll see our potato field last year. And then top left is other produce crops. This year we'll finish 600 broiler chickens on pasture that are moved every day after they're 4 weeks old to fresh pasture. We process those on farm and then market them directly to our customers. And then my largest crop is edible beans or dried beans. I started this enterprise about 3 years ago, and this year I'll have 10 acres of black beans and pinto beans combined. And those I market to grocery stores, restaurants, and a little bit direct to customers. So that's mine.
He sounds like a busy guy. Our next speaker is Grant Schultz, Mr. Permaculture, who's a local legend. If he doesn't have the machinery tools he needs, he just makes them. Grant's Iowa City farm is called Versaland, and it's a pioneering broadacre permaculture farm that produces livestock, fruit, and vegetables in an integrated system. Grant?
Hey, so I live here in Iowa City. I'm about 8 miles to the northeast. I straddle both sides of Rapid Creek that flows rapidly into the Iowa River. So every bit of rain that falls on my farm eventually flows right down the river through here. I'm reasonably early stage in my farm here. It's about 2 years in. And I went to Iowa State University. I had Matt Liebman as a professor. And I saw a lot of things that I didn't necessarily agree with in agriculture today. And I'm going to be bold here. I'm going to say that most of the speakers to date, here today have said, hey, how can we make incremental change in agriculture in Iowa? And my thought is that I don't want to make incremental change. I want to make substantive change. And to do that, you have to do things differently. And Matt Russell would state he wants to create a coalition. And I think that conflict is necessary in order to ever reach resolution. So I tend to be very polarizing. So let's see some polarization. So this is the Iowa River. This is what happens in Cedar Rapids in Iowa City. The thing that causes this is that our historical land use has changed. So when the majority of this infrastructure was built, 1910 to 1930, they're looking at historical land use patterns, and we didn't have pattern drain tile everywhere. We didn't have everything into annual based row crop production. There was some pasture. We had diversity on the landscape. Now we don't have that, and we've noticed that we've had all these increased weather events. So whether that is an increase in rainfall or an increase in land use or change in land use, it's causing some serious issues. So if we're going to farm and so produce food for human beings, what are we going to grow and how are we going to grow it? And are we going to compromise to accomplish that or not? So here is a shot of my farm in early summer. You're seeing a series of rows that happen to be kind of on contour that are capturing water. You're seeing every little white thing that you see is a tree shelter for nurturing the growth of a tree someday. So much like you've heard about the SILTs or the STRIPS program, which is prairie based on contour, I'm still putting in a perennial based crop that has a very deep root system that helps with water infiltration, but it's also a harvestable yield. So we can actually see some economic and food production off of that versus just having prairie grasses there. And they both have their time and place. You know, we talk a lot about Band-Aids. I think that a wood chip-based bioreactor to filter tile effluent is a Band-Aid. It's not a true solution. And I built an electric tractor thinking that I was going to create a better tool here. And, you know, realistically, it's not a horse. It's still, you know, a part of the transition. You might be able to fuel that from multiple means, photovoltaic cells, wind generation, or otherwise, but it still takes fossil fuel to build it. So is it a transition? Yes. Is it the perfect solution? No. I use GPS technology when laying out this system. So, you know, there's a bit of technology in play there, RTK GPS, but the idea is that you use it once to never need it again. So we're utilizing the access to technology that you have now so that we're not dependent upon it in the future. I'm not tilling everything every single year. You use this tractor to lay out a series of subsoil trenches, which then helped us establish what's known as silvopasture. Silvopasture is the integration of both tree crops and forage grasses so that we can have an overstory and an understory. Animals are grazing the livestock, but they're also benefiting from that shade of the tree. They're also benefiting from the potential yields of those tree crops. And it's all under 100% vegetation. There's no tillage or exposed soil ever through the course of the year. There's also no herbicide use. When you talk about no-till annual row crop systems, that's using typically a burn-down application of glyphosate every year. And anything that has the phrase burn down in it, I don't really want to have a part in. Not only does it, you know, remove top growth, but it kills the biology in the soil, which is bad. I'll be certified organic in a few months. It takes 3 years to transition that land. Here's how it looks on my farm. Every 30 foot, you're seeing a band of tree crops. So even if the soil is completely saturated and there's a sheet flow runoff off that land, that water flows no more than 30 feet before it hits a buffer strip. So whether that's mulch or that's a perennial forage, this is what you're looking at. You're seeing linear diversity in this. You're seeing multiple species. It's harvestable, it's mechanized, but it's not a monocrop. Here's how it looks at a little bit wider angle. We're grazing pigs in the alleyways in between, advancing that in cells as they go. It could be any other animal. I'm choosing to use pigs right now. People think that pigs, well, they survived for a few million years before we decided that we were going to harvest grain with a diesel-fueled combine and grind it up and haul it to them and put them in a concrete building with no light, locking them in there. And surprisingly enough, pigs survived for millions of years without, you know, growing in that system, and they did it by running around in the landscape. And people think, oh, they eat acorns, you know, 2 weeks of the year, but what do they survive on the rest of the year? Forage. Pigs can eat grass, pigs can eat clover. They do that. It works. So I'm super early stage. Not all the tree crops are yielding yet. Very few of them are, but in the coming years they will be. Chestnuts, apples, persimmons, pears, pawpaws, walnuts, and I could go on and on and on. Lots of diversity happening in the ground 8 miles from where we're standing right now. The idea of alley cropping, these same systems could be used to grow corn or soybeans in these alleyways. I mean, you could transition through that gray system right now if you wanted to, but you have a yield down the road. Chestnuts have a very similar nutrient profile to corn, very high in carbohydrate, totally scalable, totally storable. You can make anything with corn that you can make with a chestnut. So there is economic transition capability there. We're not just starting from scratch and having no economic yields for 15 years. You can do it and transition it effectively. I've got apples in the ground, asparagus in the ground. We're producing a lot of hay. Here's an aerial view of a system that I modeled my farm off of in Australia. You get a lot of rain one day and then nothing for a while. We had a record rainfall in April of 2013 and then a quarter-inch rain for the next 12 weeks. That's called global weirding. How are you going to deal with it? In my opinion, tile is the enemy, not the solution. We used RTK GPS technology to do this. This is scalable anywhere in the world. Here's an example of storing water and then having it available on the landscape for use for flood irrigation when you need it. Infiltrating water into the soil. You can either do it by holding on it, holding it in a swale or something to let it soak in over a period of time, or increasing the soil infiltration rate by having perennial cover, better root systems. Here's an example of a swale on my property. This entire thing is only about 5 feet wide, but you see the snow melt there. It's holding in place and it's soaking into the soil so that it's in the soil profile when you need it. Different techniques. This is an example of topography, you know, working with the soil for your row placement versus going directly up and down the hill and having high erosion. Subsoil channels to help infiltrate that water into the landscape. This is old technology, totally doable, easily done. Here's an example of our farm, using dogs as livestock protection, grazing pigs on pasture, and talking about it, God forbid. That's me. Get in touch if you want to learn more or come visit. I'm close.
It's not corn and soybeans here, huh? Our next speaker is Suzan Erem, and I don't think there's a biography in your paperwork there. Suzan is the co-founder and president of SILT, the Sustainable Iowa Land Trust. It's a statewide nonprofit, fairly new. It's dedicated to protecting land to grow healthy food. Suzan has spent 30 years fighting for economic and social justice as a community and union organizer and as a professional writer. She returned with her husband, Paul Durenberger, to Iowa 5 years ago to retire on 80 acres in Cedar County with the current situation of agriculture in Iowa, which drew her back to organizing again. Suzan.
Okay, last one. I'll keep it short. Thanks for you diehards for sticking around.
Oh, if you want to write down questions on your little notes, you can do that and make it more organized.
So I have a lot of inspiration, and this whole idea has developed over the last 2 to 5 years from a lot of people in this room. So I want to thank Matt Russell and Matt Liebman and Grant and Jason and Francis and a lot of people not in the room like Denise O'Brien and Jean Lloyd Jones and a whole list of people you can see on our website at silt.org who were all part of developing a vision of what was missing. And all this hard work, you scientists who are figuring out more sustainable agriculture, you farmers who are trying to do the right thing by the land and by the next generation. And my husband and I looking around and getting to know young farmers and understanding that no matter how good the science, unless you were really lucky or you were born right, you would never get access to the land. No matter how hard you worked, you would not be able to go into millions of dollars of debt for the land. So we looked at what was the pressure on the land, and it could be commodity prices like it was the last few years, driving it up to 12, 15,000 an acre. But you know what? When those commodity prices come down, inevitably development prices go up. So then those pressures would raise the price of the land. And the land that was most at risk was the land that needs to be closest to its market. We know that corn and soybean land doesn't necessarily need to be close to its market, right? Not if we claim to be feeding the world. But food and vegetable producers, nut growers, small livestock producers, people who want to grow healthy food for their local community, they need their land close to their markets. And that's the stuff that was out of reach. And that's the vision that created the Sustainable Iowa Land Trust. So our model is based on a lot of research from around the country on land that SILT owns, and at this moment, that's land that's being donated to us, and we already have nearly 2,000 acres. We're in conversations with owners of about 2,000 acres. On that land, for some reason, the slides aren't moving forward, but that's okay. You see that pretty farm there, that's Grant's, more of our inspiration. Oh no, it is going. It is going. Thank you. We will provide long-term leases, affordable leases to farmers. We'll lower that lease, the cost of that lease, for land that requires rebuilding, for ground that really needs some remediation. And those leases will be able to get passed on to their kids if they want. But the farmers will own the house, the barn, and the business on the land. That's where they will gain their equity, the house, the barn, and the business. That way, these beginning farmers can plow most of their resources every year into their farm operation, not into the interest payment to a bank. On land that we don't own, where farmers decide they want to keep their land in their families, but they'd like to make sure they leave a legacy of food production, healthy food production. We're talking human edible food, to be clear. They're going to be able to put deed restrictions on their land that we will enforce over time in perpetuity, that will also permanently lower the value of land, right? Because you put a restriction on land that says you can only grow healthy food, you just took it off the development market and you just took it off the commodity market. So it lowers the price of land. Now, some people say that lowers the value, but to us it means it lowers the price for the next generation. So that's our basic model. We are currently importing actually more than 90% of our food to Iowa. That's a conservative figure based on the Crossroads Resource Center, Ken Meter's work in Iowa. That tells me, since the last time I checked, every Iowan I know who's living is eating, that there's a market in Iowa for food. So we think that there are jobs out there. As for the conversion, The numbers have already been done. The Iowa Department of Public Health last year published its figures. If we just converted 123 acres per county in Iowa to food production, we could meet the USDA daily allowance for every Iowan. 123 acres. Grant's Farm is bigger than that. So we could just coordinate that properly. We could feed Iowans. I'm a little more worried about that than I am about feeding the world right now. Because we have our own poverty here. We have our own obesity here. We have our own diabetes epidemic here. So why don't we get healthy foods into the hands of our children and our citizens and then tackle the issue of feeding the world? So that's where we come from. Thank you.
Thank you, Susan. Thank you. Questions, I guess, for anyone here. What public policies would best encourage more sustainable ag practices?
I'll take it.
Go ahead, Grant.
The question was what public policies would better
Encourage more sustainable ag practices. Yeah.
I think a great public policy is the reduction of subsidies that encourage poor practices.
Can you hear?
I think that a great public policy to encourage sustainable farm practices is to remove the subsidization that supports poor production practices.
Are you talking about federal crop subsidies?
Yeah, in many ways, yeah. Yep. And I think that then that allows time for the market to readjust into a more rational system. New Zealand went through a similar transition in the 1980s where they removed federal crop subsidies for the entire country. And after a couple-year period of readjustment, the majority of agriculture on that continent and that island, which is very large and vast, readjusted to more sustainable practices and now has the highest organic crop production in the entire southern hemisphere on average for the land-based area. So I think in some cases, less regulation and less contrary public support of things that are negative actually readjust into a more rational supportive system for sustainable ag. That's a very polarizing position, though.
Any other comments on that? I'd like to ask Dick, since you're a farmer too, and what you've been doing. What would you think about regulation? If there was some regulation that, do you have any views on what kind of regulation might help, or if that would hinder? And others can comment too if they want.
Yes. As a farmer, I enjoy being able to make decisions out there on my land. And if somebody comes along and says, "Oh, well, we're going to say you need to do things a certain way," well, then I kind of don't have skin in the game anymore. It's like I'll just go ahead and do whatever they say to check the boxes instead of trying to understand that soil's a living organism. That there's a lot of life in the soil. I sent an email to Ray Archuleta lately, and was trying to get an idea on the number. And he said healthy soil has like 2,500 to 10,000 pounds of living biomass in that soil, in an acre of soil. Well, that's kind of like in the spring when I'm out there planting, I think in terms of, there's 10 calves here on every acre, and they got to have something growing so that I can be feeding that biology in the system, so that I can keep it to be that kind of a system. Well, I don't think any regulation is going to give me that perspective that I've learned from my friends in science. So
Okay.
that'd be my problem with a blanket.
Other questions? What sources of information are most important or influential as you are making these decisions about your land? People, organizations, media, science?
I can briefly respond. I'm sure others have insights too. So with our survey that I covered some, we asked questions about what are the sources of information that you trust and who do those come from. And by and large, other farmers were a strong source of knowledge, as well as university extension and scientists. And then from there, it decreases towards media, news, and government, federal agencies. So with that, I think there's a targeting of how we direct information and recommendations, and what does the science providing evidence towards, and then applying that on a location-specific basis, just with the regulation or policy. What we see in our science is, from the science, is that there's just huge variation across regions. So the regulations would have to be so detailed on a site-by-site basis, and that is not likely based on the state of the science. So what would occur is gross assumptions, and that would be hard to apply on a landscape level for many regions because it wouldn't be appropriate. So I think we have to take into account that variability as well. But for source of information, it really is kind of these perceived non-biased information sources that can best deliver it.
I have a very hard time figuring out what to believe and what not to believe. I'm a journalist by training, and we were taught to look between the lines, read between the lines of what people say. So I'm very careful not to take, at first blush, science that's been financed by large corporate agriculture interests. I'm very careful not to necessarily believe the first politician who's been funded by those interests. I am very careful about the use of the word sustainable. I've caught some flack for using that in the Sustainable Iowa Land Trust, but I said that we're going to keep it to truly sustainable in terms of closed loop systems where you have lower inputs and higher outputs, not the other way around. So it takes a lot of work sometimes to cut through all of the garbage to figure out who you can trust, and I usually start with the people I respect. And if I respect them because they work hard and they're doing things to heal the earth and provide for their community, not harm the earth and just take care of themselves.
A question for Lori and Matt. How should we prioritize field research or federal research funding for sustainable agriculture and resilience to climate change?
How should we prioritize?
How should we prioritize federal research? Yeah, funding.
So the reality is that federal research dollars are becoming more and more difficult to obtain, particularly for long-term work, which, if you're interested in soil quality or resilience against variable weather, is absolutely necessary. So I don't have a good answer to that. I speak with people who are involved in long-term cropping systems trials, and it seems like everybody in the research arena is struggling to keep their projects going year to year. Somehow we patch them together, and I think that it's a question of national priorities. Food ultimately is important to every individual, and we've taken a lot for granted, and if we're going to adapt to a new climate regime or a new set of expectations with regard to productivity and environmental stewardship, it's going to take more research. I am particularly sensitive to the need to take a systems approach which involves people from a variety of disciplines. There's no magic formula for who you need to include in your team, but there are lots of problems that are relevant to farmers as well as people who live in the environment who want it cleaner but also want an affordable and nutritious food supply that require more than one discipline. And although there's a lot of talk about multidisciplinary, transdisciplinary, interdisciplinary work, to really pull that off, as Lori can tell you and others, requires an investment of time and a building of trust among team members and members of the agricultural community that you interact with. So ultimately, we have to make a commitment nationally or at a state level to support longer-term work that builds bridges among disciplines and people in the agricultural community and the research communities and the extension and outreach community that we've been shying away from over the last, I'll say, decade or 2 decades. It's going to take a reprioritization.
And I'll just add on to that. So the team that I manage is transdisciplinary. So what that means is there's at least 20 disciplines, and it depends on how you divide some of them out. And that does take a huge time investment to not only learn one another's discipline, but also how to address these grand challenges that we face. From a federal funding standpoint, what we need to do is, I would agree with Matt, focus on long-term funding, but what happens is we tend to be a fickle people, and we change very quickly what our priorities are, and so what happens is in the funding regime that's currently in place, there are typically only a couple-year funded projects. In the past, science and academia has largely been focused on proof of concept or identifying a new area or novel area. And to prove that may only take a couple years, but when we transition to these questions of sustainability, adaptation, resilience, that's a lot more of understanding how the practices perform across a long amount of time. And for that, you need focus, vision that'll stay the course, stay the path for a significant amount of time that can see the value from investing in that. And so that just takes people that also would affirm that as a priority. For example, with our team, we're 5 years, which is actually one of the longer term funded proposals from USDA-NIFA. But even with ours, we're trying to show how you can build carbon in these systems with certain practices. But some of our soils and the resolution of the data that we're getting, we've shown that it would actually take about 20, 25 years to have enough data to show change from those practices. So that's the problem when we have only a couple-year funding projects. It's just hard to show change. And so then what happens is we end up in these isolated disciplines doing little small pieces of research that don't tie together. And I hope data science and some of our computational abilities now will help to bring those isolated disciplines together to identify some of these grand challenges and solutions for them.
Okay, a question for Jason and Grant. What are your recommendations to younger farmers or those considering going into farming?
Coming to stuff like this, getting involved with organizations like Practical Farmers of Iowa here in Iowa, getting to know other farmers, like offering to work for them, even if it's 1 day a week, trying out every different type of enterprise. So if you're not sure if you want to do livestock or if you want to do produce, try out everything. Don't just dive into it and think you're going to farm right away, because you might not like the 18 hours a day kind of thing for 12 months of the year. So it's good to try that out. Yeah, and I would say make sure you see all different types of perspectives, so that you have a clearer vision of where you want to go.
I would say that if you're coming from a family farm, go work for someone else. Go get some broader experience elsewhere, even in your same region or elsewhere. So you're not doing exactly what your folks did. And maybe you want to do that. Maybe you've realized that's a great thing, but you need to be able to have something to compare that to. And most importantly, I think that you should get a broader perspective of agriculture. And you can move all around the world and volunteer and live for free and get a nice place to stay and a full belly and learn from people, in the Ukraine, in Australia, in New Zealand, in Lithuania, in Florida, wherever. Cedar County, yeah. So broaden your lens, I think, is really important.
A follow-up question on that, Grant. In your permaculture system, when it's mature, how do you think the profitability will compare with corn and soybeans? And how long will it take to get to that maturity state, you think?
When my farm is mature, I think it will be much more profitable on a per acre basis than my neighbors. The biggest input there is that your net profitability is the highest when you have the lowest inputs. And at that point in time, I'll have essentially no purchased inputs. So it's significant. In the meantime, I'm still profitable, and I'm making that transition happen, paying, full market rent. It works out to $550 an acre in cash rent right now, which is 2 to 3 times what most producers would be willing to pay, because I'm intent on making that transition happen. And it's still paying the bills. It can be tight for a while, but it's still happening. And I need to be very blunt about that. But if you don't make that transition happen, you're in a world of hurt in the very near future, in my opinion.
Yeah.
Grant's kind of farming, which I'm familiar with because he's taught me so much, is we were talking about externalized costs and internalized benefits. That farm is stopping this sheeting water into the rapid creek that was making it fly during the spring months. And that's a community benefit. I was trying to get Bill Stowe to mention this because he's on our board, but he had to go early. But the bottom line is that if we had farms like Grant's and farms like the ones that the Sustainable Iowa Land Trust wants to protect all along our watershed, we wouldn't have to sue anybody. Those farms would be the buffers that we need for the other farm operations to do what they need to do.
Jason, kind of related question is, how do you deal, for farm-to-school programs, how do you deal with the problem of trying to get a fair price that could support local producers versus what the schools are paying, often cheap prices for their institutional food?
We don't sell them the stuff that they can't pay a good price for. Well, they may be able to pay a good price for it, but things like head lettuce or leaf lettuce, we tried that once, we'll never do it again, primarily because it takes so much labor for small vegetable operations to harvest enough lettuce for school. But we found things like cucumbers, zucchini, broccoli, potatoes. I mean, I've been selling potatoes to schools for $1 a pound, and I'm perfectly fine with that. So it's so dependent on the product and the commitment of the school district. Schools can make even though they have to take a competitive bid comparing buying produce from Reinhardt or Lafredo produce, they can make a commitment to local, and they can pay a little bit more for that because the local cucumber is not really the same thing as the non-local cucumber from Lafredo. So they can say those are two different products, and they can say, I'm going to agree to pay more for that one. As long as it's not like 30% more, it needs to be within their budget. So, it depends on the district. I mean, Iowa City here, we started working with them probably 5 years ago when I started talking to them, and in the transition of a new school food director, when that new director was hired, it became a part of their job description to do farm to school, so she has no choice whether she wants to do it or not. It's part of her job now.
Well, it's getting kind of late. Anybody have any comments they want to make yet that we don't want to leave anybody out? I guess probably it's time to wrap it up then. Thank you.